Right now on the National Weather Desk, tens of millions face the threat of severe storms today and this weekend. Major event organizers are making sure visitors stay safe.
In the event of lightning, we do shut down for a minimum of 30 minutes each time.
Dust from Africa's Sahara Desert spreads over the southeast.
Now, this Saharan air layer has a lot of advantages and some disadvantages.
As we mark the anniversary of D-Day, we'll take a closer look at the critical role meteorologists played in its success.
Calculations had to be done by hand, and forecasts more than 24 hours in advance were highly uncertain.
Why were so many places able to witness the northern lights earlier this week? And we have another installment of Social Meteorology, where our meteorologists help you better understand the weather.
From our nation's capital, this is the National Weather Desk.
Good morning and welcome to the National Weather Desk. I'm meteorologist Eileen Whalen. Well, it has been a very busy spring for severe weather. The Storm Prediction Center says there have been more than 1,000 tornado reports so far this year. That's about 30% more than a typical year. There were 25 more reported yesterday, including this tornado near Lubbock, Texas. The National Weather Service received reports of damage in the area, including snapped power poles, downed trees, and blown out windows. At least one person is believed to be hurt. To the west, a rare hailstorm battered Las Vegas and the surrounding area. The hailstones were fairly small, pea to nickel size. Now that system also produced heavy rain, and in the desert, that much rain can quickly lead to flash flooding. Monsoon season here begins later this month. More than 32 million people face the risk of severe weather today. The biggest risk is once again around Lubbock, as well as eastern Colorado and western Kansas. But as you can see, the area in yellow extends from Denver to Tennessee and Kentucky. Now, these severe thunderstorms could produce very large hail, damaging winds, and tornado threats. Another city in that high-risk area is Nashville, Tennessee. And this week, nearly 100,000 people are in Music City for the annual CMA Fest. Now, the threat of severe storms is very much on the mind of both organizers and festival goers. Hope Salmon shows us how everyone is preparing for the storm threat.
Music City is known for its tunes, and this weekend, people from all over the world are heading downtown for the CMA Fest, rain or shine.
We've been trying to pay attention, but we're like, where's the music?
The music will be loud, and thunder may make some noise too, calling for heavy rain, strong winds, and lightning.
We came here a month ago, tornado warning, sideways rain, and we're like, gotta take it a little more seriously.
Genevieve isn't the only one keeping a close eye on the skies. Honky Tonk managers like Austin Howard at Ole Red say they're ready for big crowds and bad weather.
Yeah, we've all got sheets, and every floor's got what we call it, an SOP, an operating procedure, all that good stuff.
Howard says each floor has protocols in place to make sure no one is near windows or doorways in case of severe weather. Metro Police and CMA officials say they're also prepared.
We have contingencies in place, and those will be announced when the weather comes in, where to go, the shelters that people can go to.
Sarah Traherne, CEO of the Country Music Association, says the show will go on unless there's lightning.
But in the event of lightning, we do shut down for a minimum of 30 minutes each time.
Severe weather is expected in the south through the weekend as well, and those storms could include damaging downbursts. Meteorologist Evan Chikvara explains what they are.
We'll start with a look at a thunderstorm that occurs in the summertime. Vertically, these can go 30,000 plus feet. It's pretty high in the atmosphere. That's rising air. That's vertical motion. That means hail cores at times, lots of rain, and all that eventually has to come down. So how the heck do we get from some cumulus clouds to this setup? So of course you have your inflow. This is the updraft. That is what is fueling these thunderstorms. Eventually it gets to a point of kind of equilibrium. You've got updrafts going in, but you also now have downdrafts going out of the storm. Eventually there's so much mass within this thunderstorm that it can no longer be supported by the updraft. And guess what happens? All of that comes down in one spot. If you've ever turned on a sink faucet, the water goes down straight out into the sink. That's a lot like a downburst. So what is a micro versus a macro? Well, it's as simple as the size. You look at a microburst, this is going to be less than 2.5 miles in diameter. That's pretty small. That's a concentrated area of heavy rain, sometimes hail, and gusty winds. Very tough to predict, but very common in the summertime, and they can be damaging. A macro burst just happens on a larger scale, usually part of a larger thunderstorm, and these can be a little bit more impactful given the overall size.
A damaging hailstorm slammed many farms and ranches across a couple of Texas Panhandle counties Wednesday night. It has some farmers and ag producers concerned about their livelihoods. Drew Powell reports.
The noise is what, wakes you up and says it's real.
Man, it really come down, made wind and broke limbs and knocked out skylights and tore up my roof.
Now, for ag producers and farmers that insure their wheat crop, it's break even at best or lose just a little. But for the producers that choose not to insure their crop, once it's damaged by hail, it's lost. Once they're done checking their fields, they say it's all about monitoring the weather, keeping an eye out for what comes in next.
That plume of dust from the Saharan desert is now spreading over the southeast. This morning, it's giving skies across Florida a hazy, milky appearance. And later today and tomorrow, it's expected to push as far west as Texas, as well as into Georgia and South Carolina. West Palm Beach meteorologist Michael Ehrenberg has more.
Outside here in South Florida, where it's a lot of clouds, but you might notice something else. It's called the Saharan air layer, a lot of haze and dust across our skies. This is dust from the coast of Africa that's come all the way across the Caribbean and the Atlantic. Now, this Saharan air layer has a lot of advantages and some disadvantages regarding the weather in the tropics and here across the Sunshine State. Here's more. The Saharan air layer is typically found in the Atlantic from now through early fall. It's located about a mile or more above the ground, and it's about 2 to 2.5 miles thick. It stabilizes, cools, and dries out the atmosphere so it can limit tropical development and thunderstorm activity from developing over Florida. It can also produce vivid sunrises and sunsets. That's a look at the SAL, or Saharan air layer.
We're tracking the tropics this morning. The National Hurricane Center is now monitoring 2 disturbances off Mexico's Pacific coast. Now, the one we told you about yesterday now has an 80% chance of forming into a named storm in the next week. It's moving west-northwest. And then the second one just to the west has a 60% chance of developing into the next named storm. The next storm to form in the Pacific will be named Barbara. Today marks 81 years since D-Day. The turning point in World War II hinged on a successful weather forecast. Meteorologist Douglas Harlow takes a closer look at the forecast that may have saved the world.
At that time, there were no supercomputers to accurately simulate the atmosphere. Calculations had to be done by hand, and forecasts more than 24 hours in advance were highly uncertain. Observations from weather stations were critical, and there weren't many of them. A successful landing in Normandy required 3 things: a full moon to provide good visibility, low tide to aid ground troops reaching the beach, and good weather. Now, the full moon and low tide combination was met during the June 4th to 7th period, but it wasn't going to be met again until June 18th. And a key to the success of the operation was surprise. So any delay later into June meant an increased risk that the Germans would learn of the plans. The big question was the weather forecast. A team of 6 meteorologists from the UK and US was headed by Captain James Stagg. On June 3rd, the weather in the English Channel was quite favorable, and an initial invasion date of June 4th had been set. But Stagg knew that weather systems generally move from west to east in the northern hemisphere, so he was closely monitoring weather observations being relayed from lighthouses on the west coast of Ireland, just about the westernmost point in Europe. Stagg believed the weather conditions in Ireland would translate to the English Channel within 24 hours. Maureen Flavin and Ted Sweeney were lighthouse keepers in the town of Belmullet on the western Irish coast. Their weather report on June 3rd was not favorable, reporting strong winds and heavy rain. Believing deteriorating conditions would spread across the English Channel by the next day, Stagg recommended to General Dwight D. Eisenhower that the operation be delayed. Eisenhower took his advice, and the weather did worsen significantly by the 4th. Stagg continued to watch conditions in Western Ireland in hopes of improvement, and later on the 4th, he got the news he wanted. Lighthouse keeper Ted Sweeney reported heavy rain, drizzle cleared, cloud at 900 feet, and visibility on land and sea very clear. Stagg relayed the improving weather conditions to Eisenhower early on the 5th, and after a moment in deep thought, the general said, "We'll go." The forecasted break in the weather came to pass, and troops landed on the French shoreline early on the 6th. In 1961, when John F. Kennedy asked Eisenhower how D-Day was so successful, he replied, "Because we had better meteorologists than the Germans."
You are watching the National Weather Desk.
When climate change discussions occur, shrinking glaciers and rising seas are key issues. But what does a warming Earth have to do with your seasonal allergies? And why? Fallon Mears explains.
As we continue to increase the amount of carbon in our atmosphere, we're increasing the ability for these plants to create that pollen, which may sound like good news in terms of plants being able to thrive, right? But what it does is it makes that pollen process more intense.
That means more pollen as well as a longer allergy season, which is bad news for those with sensitive respiratory issues like chronic obstructive pulmonary disease or asthma.
One of the papers that we studied also showed that there's about 20% more pollen in the atmosphere as compared to 50 years ago.
A longer growing season means the need for more allergy meds.
Studies do show that the pollen itself is more allergenic, meaning that it produces more severe allergy symptoms. So the sneezing, nasal congestion, postnasal drainage.
This year has been particularly difficult. Patients have said that it's been one of their worst seasons, and it even has started earlier than previous years and is lasting longer than previous years as well.
One of the potential reasons for that is if there's new trees or plants that are growing in that environment and are able to produce pollen that you are allergic to, that could be one of the reasons that you're now feeling pollen allergies and in the past did not.
This week, several parts of the country had the chance to see the northern lights. This was due to a solar storm that took place last weekend. But how does what's happening on the sun light up our night sky? Meteorologist George Waldenberger explains.
The northern lights are an interaction between the solar wind and the Earth's magnetosphere, an extension of the Earth's magnetic field into outer space. Without it, the solar winds would likely strip off our atmosphere. So that interaction actually allows some of these high energy particles to get caught in the magnetic field or the magnetosphere. And at the poles, there are two cusps. They're basically entry points into our atmosphere through which some of those high energy particles can flow. Now, every once in a while, you get an outburst of more of these high charged particles in the solar wind. And when that happens, you have more of them coming down into the cusps. And it's not actually those high energy particles, though, that generate the northern lights. It's those particles impacting with gases in the atmosphere. It excites them to a highly energized state, and then they glow as they go back to their normal state and give off some of that energy. Oxygen, excited to a certain state, can glow as green. That's one of the common colors. Oxygen, excited to a different state, can glow into a red, and nitrogen can show off into a blue. Now, some of these events that we see, they don't happen every day or even every week. The severe geomagnetic storm that we saw over the weekend happens on average maybe 100 times over the course of 11 years. So definitely notable, but we'll get another one if you missed this one, and hopefully you can check that one out.
And now time for a segment we call Social Meteorology, where we show you some of what our meteorologists across the country are posting on social media. We begin with Tara Blake and why clouds sometimes look dark.
When you see a dark cloud, you know it's time to go inside. It's about to rain, right? But do you know why? Hi, I'm meteorologist Tara Blake. So first let's talk about the composition of a cloud. It's made up of condensed water vapor, water droplets. And as the sun beams down on those water droplets, the white light is then reflected, showing you that beautiful white puffy cloud in the sky. But then, as warm air rises, the cloud starts to get taller, denser, and thicker, and the sun is unable to penetrate through. Some of that light is being absorbed or reflected, but you're getting almost the shadow at the bottom of the cloud for what you see. As the raindrops, the water droplets continue to grow and increase, the cloud gets darker, and that's your signal to head inside.
Have you ever noticed why rain has a smell to it? Well, let me tell you why. It can be one of three things, so let's get into it. Well, soil-dwelling bacteria release a chemical called geosmin, and raindrops help release this earthly smelling chemical into the air. And the second thing that can cause the smell is actually from plants. And when it's dry, plants release oils. Rain causes a smelly compound, which is called petrichor, to be released from those oils. Lastly, lightning can split oxygen molecules into individual atoms. Those atoms can combine with the O2 molecules to make ozone, which has a distinct smell. So next time you're outside, that's what you're smelling.
Let's talk about the difference between partly sunny and partly cloudy. Do you know the difference? We start with the easy one, sunny and mostly sunny. And we all do it through percentage of cloud cover in the sky. Between 0 and about 25% is sunny to mostly sunny. Here's where it gets tricky. When we say partly cloudy skies, that means there's more sunshine than cloud cover in the sky. I know, it's a little confusing. Anywhere between 26% through about 50% is partly cloudy. Then we get to partly sunny, which means that there's going to be a little more cloud cover than sunshine. And that's going to be anywhere between about 51% through about 74%. Then we add more cloud cover, about 75% through about 89%, mostly cloudy. And then anything above 90 to 100% cloud cover, it's cloudy outside. Now, a lot of meteorologists will use the partly cloudy to partly sunny interchangeably, but hope that clears up a little bit for you that yes, partly cloudy actually means there's more sunshine.
AJR is an indie pop band that has been topping Billboard charts and filling up arenas. But what you may not know is that their bass player is a climate scientist. This week on our podcast, Off the Radar, Emily Gracie sat down with Dr. Adam Met to learn about how the band has been using the stage to inspire climate action. Here's a preview of that episode.
AJR, the indie pop trio turning chaotic anthems into viral hits. The Billboard Music Award-winning brothers, Adam, Jack, and Ryan, have been blowing up social media and selling out arenas with hits like Bang, Weak, and The World's Smallest Violin. But what you might not know is that the band's bass player isn't just a rock star, he's a climate scientist. Now, along with his two brothers, he's harnessing the power of fandom to bring change to the future of our climate.
I looked at how we built this fan base, and I said, okay, what if we could do the same thing, but for the climate movement?
Today, we're going off the radar with Dr. Adam Met to explore how art and activism intersect in ways you've never heard before, bringing the climate crisis center stage to a whole new audience, one arena at a time.
A good story is one that you hear and you're like, oh, that's cool, and you'll share it with your friends and family. But an effective story will actually make you get up off your butt and do something about it.
And you can find Off the Radar anywhere you listen to your favorite podcasts. New episodes drop every Tuesday. And time now for a short break, but first we take in views over Yellowstone National Park.
You are watching the National Weather Desk.
The Atlantic tropical season is merely days old, but it lasts 6 months through the end of November. So what ingredients are needed for hurricanes to form? Meteorologist Kit Alexander explains.
The fuel for tropical cyclones is very warm, moist air. In fact, the air needs to be at least 80 degrees for something to form. The abundance of warm, moist air helps to fuel the tropical storm and sustain it. Another important factor is strong winds that converge, forcing the air upwards. Similar to an air mass thunderstorm, you need something to act as a lifting mechanism to develop the storms. Once there's a system of storms in place, Coriolis force, due to the movement of our planet, will get it rotating, as long as it's just about 5 degrees away from the equator. In the upper levels, you do not want winds opposing the storm. That would be shear in this case, and shear will weaken the tropical cyclone. As many of you know, hurricanes are based on the Saffir-Simpson scale. The intensity varies between a category 1 through 5, with a category 5 being the most destructive.